harder. Is that better? They're not the same as what you've just been doing. You did exercises yesterday. Today I want to escalate that and talk about problems. Things that you'll have to wrap your mind around. Now, I have a couple of different scenarios. I think we'll get through 3, maybe 4 of these problems. And I don't expect that they will take you as long for you to do them for homework, but I think in here we do need to be thoughtful about them. Does that make sense? So here's the first one. And I could write the whole problem down, but that takes me time, and I'd rather not. So I will tell you the problem. You, in your car, that's your car. Isn't it lovely? You are traveling at 40 meters per second, which is probably too fast. That's about 85 miles an hour. When you pass, that car's even worse. A police officer who is currently at rest. The moment you pass the police officer, him noting that you are in an excessive rate of speed, he begins to accelerate to catch you. And he accelerates at 2 meters per second squared. How far does he have to travel until he will overtake you? That's the question. You travel at a constant rate of speed. He, starting from rest, accelerates. Both of you begin at the same place. How far until he has overtaken you? You have all the information you need to solve this question. You may not have the experience you need to solve this question, but you have all the information you need to solve this question. This is a multi-body problem. That's what I like to call it. There's more than one object. And the first clue I will give you is that in any multi-body problem, your road to success is that you understand that each object gets its own set of motion variables. So if you want to succeed here, perhaps have the police officer and you as separate motion variables. And then from there, maybe you can draw some comparisons. So I'll give you a moment to see if you can eke out the information I've given you. So, how many of you have filled in everything you can? There's not that many things to put in here, is there? The police officer begins from rest. That one's easy. And accelerates at 2 meters per second squared. And that's it. That's all we know about the police officer. You, however, we know a lot of things. We know that your initial velocity is 40 meters per second. But you're traveling at a constant rate of speed. So we know that your final velocity is also 40 meters per second and your acceleration is 0. Now that might seem like we know a lot of stuff, 3 pieces of information. But if you're careful, you'll realize that you really don't know very much. Not as much as you might think. Because although we have 3 pieces of information, what happens to these when A is 0? First, V equals V naught. Yeah, you didn't accelerate, so your velocity stays the same. V minus V is 0. Yep, that's going to happen because A is 0. V squared minus V naught squared is going to be 0. So that leaves us with these 3. And when A is 0, the 1/2 AT squareds go away. And in this case, V and V naught are the same, so 1/2 times 2V is just V times T. they all become the same equation. Delta x equals v times t. The 8th grade one, right? Distance equals rate times time. Nothing very valuable. The problem is that you still don't know distance or time. Now, you only have 2 pieces of information for the police car. So you can't assess which of these 3 to use either. So that makes this harder, but that doesn't mean it's impossible. You do know something else. There is a 3rd piece of information you can bring to bear. It takes you the same amount of time for you to travel the same distance as the police officer. You and the police officer are going to have the same displacement in the same amount of time. Therefore, you should be able to create 2 equations that have 2 of the same unknowns. For example, start with u. Delta x equals 40 times t. Easy place to start, correct? Well, if I ignore final velocity, I should be able to construct a relationship that has a delta x and a t in it. Two equations with 2 unknowns. These 2 can be solved simultaneously, meaning substitution or something could be used to generate the result. So first, does everybody understand where I got this and where I got this? Yes, sir. The which one? This one here? I chose to use this relationship. And in that relationship, I put the acceleration as 2 and the initial velocity as 0. But I don't have delta x or t, so I had to leave those there. Just to corroborate what I said yesterday, remember, since I x'd out final velocity, I went to the chart where final velocity is and chose the relationship that has everything but final velocity in it. And that's how I chose it. Now, knowing that these 2 variables are the same and that the times are the same means that I could now do substitution of some sort or another. Yeah?
Just a quick question, sorry. On the final AP exam, did you need to have all those formulas memorized?
What I'd like you guys to do is go ahead and solve it. It's not much to do here. There's a variety of ways to do it. Most people realize that you can just set these 2 equal to each other. But I want you to do something for me. If you're going to solve it by setting this equal to this, raise your hand if that was your plan. Okay. That's what a lot of people do because they're already solved for delta x. Now, we actually want delta x as our answer. But if you're doing that, please do it correctly. And I know you don't necessarily know what I mean by that. So please pay attention. 1/2 times 2 t squared plus 0 times t equals 40 t. Now I can get rid of the 0 t and get t squared equals 40 t. I know there's a desire to cancel out a t. That's bad math. Correct math would have you, what is going on there with my pen? Correct math would have you move the 40t to the other side and then factor out a t and then set each factor equal to 0. And get 2 answers. Now I know what you're thinking. Why? I want you to notice something that I think has value that you guys as students tend to ignore due to lack of experience, I think. we asked mathematics to give us information. I know what we asked of the mathematics. I'm not always sure you do. I think you set things equal to each other and solve and write down whatever number comes out. But we asked the mathematics to tell us when the two objects were in the same position. Right, that's what we did. We made the assumption that they had the same displacement in the same amount of time. And when we did it correctly, mathematics provided us with 2 times. That's not accidental and it's not arbitrary. There were 2 times when the police car and you were in the same position, at the start and at the end. And the mathematics supports that. The reason I bring this up to you is that you will often ask mathematics for an answer. And sometimes the answer might not always make sense to you. So did you choose improper mathematics, which is possible, or do you fully appreciate what the math is telling you? I would encourage you always to do your math using the best mathematics principles possible, because you will find that the answers you get should corroborate what you are looking for. So if you treat math like a tool and just a function, you won't always understand that. If you treat math like a science, that it's giving you something that you were asking for, you may find that your answers are more meaningful. And it will also help you understand why it is we don't throw away the 1t. That 1t had meaning, very specific meaning, and here's where it comes out. So I know it seems like overkill. We know the answer is 40 seconds. I just like you to make sure you understand that there will be times where maybe looking at both answers has value. We're not actually done. The problem wasn't about how long it takes to reach the other person, but where they are. And I hope you realize that the easiest way to find that out would be here. All right, you can go to the other one, but this one will be the easiest. And I think we find that it's 1,600 meters, so you travel about a mile. So, okay. I think it's kind of fun to figure out how fast the person's going too. The police officer has to catch you from rest, which means they'll eventually have to exceed the speed you're going so they can catch up to you. If they only made it up to 40 meters per second, they would never catch you. So they clearly have to exceed that. And that 80 meters per second is, like 190 miles an hour. Let's hope they actually don't do that. Maybe they'll take an extra mile to catch you and bring their speed down a little bit, because that would also mean a closing speed of about 85 miles an hour as they approach you. That's pretty fast closing speed. This is, of course, why high-speed chases aren't always the best. So maybe next time you pass the police officer and you see him whip out behind you, just go ahead and slow down. You did something wrong. Maybe it's time to take your medicine. As opposed to, maybe they aren't coming after me and then you just slow to the speed limit. They're coming after you. Yeah, you're not going to get that lucky. So, but let's say I have a toy car that takes batteries. And when you turn the car on, the car will accelerate up the ramp due to the batteries at 2 meters per second squared. But the batteries only power the car for 5 seconds, meaning that the car travels that way for a total of 5 seconds. And then the batteries shut off and the car obeys whatever the track makes it do. Does that make sense? So the track takes over and then the car is pulled down the track. So you start the car at the bottom of the track and you turn the car on and the batteries power the car for 5 seconds and then shut off. Where does the car come to rest before turning around and going back down the ramp? This is a different kind of question. The last question we had was a multi-body problem. This question is a conjoined problem, where the events of one part of the problem affect the events of another. Same object, 2 different accelerations. If you want success in this problem, please consider 2 separate sets of motion variables. Remember, this set of motion variables can only handle constant acceleration. Since the car experiences two different accelerations, that suggests you'll have a set of motion variables for one acceleration and a different set of motion variables for the other set of accelerations. So two sets of accelerations, and therefore two sets of motion variables. Try laying it out and see what happens. Minimize the importance of following through. What I'm saying is once you know how to solve this problem, the actual ability or activity of solving it is far less at your level and below your level, if you know what I mean. So let's see if we can figure out a method to solve the problem first. And then from there, if we have time, we'll solve it. Does that make sense? Because there's another one I'd like to take a look at too. As I said before, you should start by identifying that there are two sets of motion variables. Now, I've not made this a seminal point yet in this class, but it really needs to start being one. 4 of these are vectors and have direction. I think it's natural to indicate, up the ramp as being positive. But you need to probably start getting in the habit of identifying what you are going to call the positive direction of a problem. Because oftentimes making a choice about what direction is positive is better for you. And it helps illustrate also what it means when you get negative answers. So I'm going to say up the ramp is positive, which means I believe that the car's initial acceleration is going to be positive. And it seems to me the car's starting from rest. And we know that the car's initial progress up the ramp is timed for 5 seconds because the batteries will cut out after 5 seconds, at which point this acceleration will no longer exist. Well, that's 3 things. I could solve for all sorts of stuff. Of those, I could figure out how far the car goes. Now, the moment the batteries cut out doesn't mean suddenly the car stops, right? When the batteries cut out, there will suddenly be a new acceleration that is down the ramp. If I'm trying to figure out where the car turns around, I want to know where the car has a final velocity of 0. That's still not enough, and I don't have any other information from what was given to be able to solve the problem. I need 3 pieces. Here's where we need a deduction, a piece of logic that could help us solve the problem. Does anybody have this piece of logic? Yes, sir?
It's travel 2 meters per second for 5 seconds. The velocity would be 10 meters per second.
The what?
The velocity would be 10 meters per second.
Which velocity? Because I have several available V's. Okay, so you used V equals AT plus V naught. And I'm saying this for the other people who may not have followed your line of reasoning. And that means 2 times 5 plus 0 gave me 10 meters per second at the end of the interval. Great. Can I use that to do something else? That still doesn't help me with the right side. Yes, sir?
So by the time the 5 seconds are over, its final velocity is 10 seconds. But by the time the 5 seconds are over, its acceleration switches over to the right side. So then that final velocity switches to the initial velocity.
Perfect. That's the leap of logic. I'm sure a couple of you made it because I could see you doing this. This final velocity becomes the initial velocity for this interval. It has accumulated this much speed, but now the acceleration is going to take that speed away. Doesn't happen instantaneously. So suddenly now we have 3 pieces of information here that we could use to deduce delta x. Now we need both delta x's, by the way. But yeah, that'll do it. So if you guys came to that conclusion, great. If not, look for that. That's a great way to go. I think this one ends up being 25 meters, and this ends up being 33 1/3 meters. So if you're trying to check your work, that's the way to go. The actual answer would be the sum of those two. So what, 58.3 meters would be how far it goes before it turns back. plugging it into the equation's not interesting, I'd like to look at something else. Is that okay? Or do you want the time to plug it in and get numbers? I just don't think that that's as good a use of our time.